Hey guys, I didn't see you there. This is Mr. Pathos, the chemistry teacher here at Rhetoric High. Today I want to teach you all about the gas laws. Gases are fascinating. There's so much to learn, and they're so much better than liquids and solids. For example, gases are compressible. Liquids and solids, they're not. That's why I want to teach you all about the gases. So, there are 4 properties that you can compare to learn all about the gases. I'm going to introduce them to you now. Look who it is. It's my friend Volume.
Oh, hey, Mr. Pathos.
Hey, Volume, how are you today?
I don't know. I've been really stressed. Haven't been eating a lot.
Really? What kind of effect does that have on you?
When I don't eat a lot, I tend to be really small.
Whoa, what happened to you?
I got a little snack. Sometimes after a few Jimmy Johns or a large order of orange chicken, I get a little large. That's why I always have to be measured. My mom likes to measure me in liters. My doctor likes to measure me in decimeters cubed. But sometimes I get measured in milliliters, and sometimes I get measured in centimeters cubed.
Fascinating. But for our purposes, we'll be measuring her in liters.
All done. I think I'm going to take a lunch break. Nice seeing you, Mr. Pathos.
Later. Pressure, where are you going?
Oh, hey, Mr. Pathos. I didn't see you there. How are you?
I'm good, how are you?
I'm not good. I'm so stressed right now. I'm under so much pressure.
Why?
I don't know. I have this big midterm coming up on Wednesday. I'm not ready at all. Those gas laws, I just can't understand them. The pressure, the volume.
I completely understand. Why don't you go study and come back later when you're under lower pressure, okay?
Thanks.
You're welcome. Hey, Pressure, how you feeling?
Hey, Mr. Pathos. I'm feeling a lot better. The pressure has definitely been taken off.
That's great. I'm glad to hear that. How'd the studying go?
It's going really well, but I'm still having some problems with Boyle's gas law.
All right, well, let me see if I can help you with that. Why don't you go take a seat? So, just like volume can be measured in different units, so can you, pressure. Your units are atmospheres, milligrams of mercury, and torr. Now, for Boyle's law, it states that pressure times volume equals a constant. So, because pressure and volume are on the same side of the equal sign, that means that they're inversely proportional. So when pressure is high, volume is low. And when pressure is low, volume is high.
Oh, I get it. That means if I'm low, then I'm large. And it must mean that if I'm high, I'm small.
Exactly, guys. You got it. But there's also 2 more laws. The first one is Charles' law, which states that volume over the temperature equals a constant. Now, because temperature is in the denominator and volume is in the numerator, that means that they are proportional to each other. So, when volume is high, temperature is high. And when volume is low, temperature is low.
Hi, I'm temperature. When I'm high, I'm low.
Hi, I'm temperature, and when I'm low,
I'm small.
And there's one more law, that's Gay-Lussac's law, and that says that pressure over temperature is equal to a constant also. So again, because temperature is in the denominator and pressure is in the numerator, they're proportional. So when pressure is high, temperature is high. And when pressure is low, temperature.
So when I'm high, I'm high. And when I'm low,
I'm low.
Before we can talk about the ideal gas law, there's a few more people I need to introduce you to. One of those people is R. Whoa, R, when did you get here? How are you? Really, you don't say. R is kind of quiet. In fact, R is always constant. Because R is so quiet, let me explain for her. R doesn't really have much of a personality, so it relies on pressure, volume, and temperature to tell what unit to use. When pressure is in ATM and volume is in liters, it uses 0.08206. When pressure is in kilopascals and volume in decimeters cubed, 8.31451, and so on. You can see right here. That's how R is used. Okay. Oh look, here comes moles. Moles and volume are really good friends. So good, in fact, that they're directly proportional to each other.
When I'm large,
I'm large.
when I'm small,
I'm small.
So, when we put everything together, we get the ideal gas law, which states that pressure times volume equals N, the number of moles, times R, a constant, times temperature. Remember, the temperature always has to be in Kelvin, and the rest of your units always have to match. Now, there's three assumptions that the ideal gas law makes that really says that an ideal gas law is in fact not ideal. So, the first assumption is that there are no other forces acting on the molecules besides the intermolecular attractions. The second states that all of the collisions between the molecules are perfectly elastic. And the third states that the gas has enough room to move around freely. So, when you take that into consideration, we find that no gas is truly ideal. But this is the equation that we use to compare the four components of a gas: pressure, volume, temperature, and the number of moles. I really hope that I've helped you learn more about the gas and its components. They are so fascinating, and I hope that you find it as exciting as I do. So, take this equation and use it wisely. This is Mr. Pathos, and I'm signing out from Rhetoric High.